Thank you for joining me in today's program. We are still under factorization of algebraic expressions, okay? So we have to show another algorithm we can still use to divide a polynomial. This algorithm we call synthetic division. All right, it's a different, unique, but very fast algorithm we can actually apply when dividing a polynomial by another polynomial. Just like long division algorithm, which we treated in our last lesson, that is video 1.6, okay. The result that we have to have after synthetic dividing a given polynomial by a linear factor is what we still have, okay, in our usual long division method. So, let us give an example. Okay, the main thing about this algorithm is that it is very fast. It does not take time, unlike the usual polynomial long division. All right, so we have this polynomial f of x to be divided by the linear factor s plus or minus a, where a is some number, f of s is a polynomial. Okay, then the whole s plus or minus a is the linear factor, is equal to s cubed minus 7x minus 6 divided by x minus 4. So our aim is to find the division of this, okay? Usually we are to use we normally use long division, but in this case we use synthetic division, so we do. By synthetic division, since the linear factor here is x minus a, just let us use x equal to 4, okay? Or simply, well, let us set x minus 4 equals to 0, such that solving for x, we have x to be what? Equal to 4. That is x minus, not plus, please, x minus what? 4 equals what? 0, okay? Such that solving for this, we take minus 4 to the right hand side, we have x to be what? Equal to 4, okay? Now here we have to use what? 4 as our what? As a number we can use to what? Divide. So we write out 4 here, draw a line, okay? Inside the line we have to write the coefficients of the what? Polynomial, okay? So for the cubic term we have 1 as the coefficient. For the linear term we have mind you, here there is no quadratic term, so let us insert 0 in place of the quadratic term, showing that we have 0s squared, okay, which is still nothing. So here for the linear term we have minus 7, for the free term we have minus 6, okay? Please just listen up. The process is very short and very clear to our world. Understand. First step is gone. So second step is bring down the first term, which is 1. Bring it down here. Now multiply this 4 by 1 to have 4. Place it here. Again, bring down, sum up 0 and 4 to have what? 4. That is 0 plus 4 is 4. Again, multiply 4 and 4 to have what? 16. Now, sum up minus 7 and 16 to have 9. Again, multiply 4 and 9 to have 36. Again, sum up minus 6 and 36 to have 30. We are done. Unlike long division, whereby we waste time. Do you see? Just write in standard form x squared. Mind you, the first term of the original multinomial is s cubed, okay? But after the synthetic division, what we have remaining here, the first term now, 1, will be multiplied by the quadratic term, 1 times x squared plus this 4 multiply the linear term, 4 times x plus this expression term here is now the constant 9. Then plus this 30 here is now a remainder all over the factor x minus 4. Okay, so 1 times x squared is x squared normal. Okay, plus 4x plus 9. Okay, plus 30 over the linear factor x minus 4. All right. Okay, so that is it. That is how we can actually evaluate or use synthetic division to divide a polynomial by a linear factor. Okay, hope this is helpful, right? Let us give another example. Copy this out. Let us show another example. Still on synthetic division. Okay. Now, suppose we have 6s raised to the power 3 minus 5s squared plus 4x minus 17. Okay. Divided by x minus 3. All right, by synthetic division, what we have is let x minus 3 equals to 0 such that 3 becomes our what? Divisor. Now we draw the line, bringing out the first term coefficient, which is 6, bring out minus 5, bring out 4 from the linear term, then from the constant, bring out minus 17. The first term, bring down 6 here, multiply 3 and 6 to have what? 18. Sum up minus 5 and 18 to have 13. Multiply 3 and 13 to have what? 39. Sum up the result 4 and 39 to have 43. Multiply 3 and 43 to have 129. Sum up the result of minus 17 and 129 to have 112, 112. Okay, so we are done with our division now. Since the highest term here is raised to the power 3, the result will now be 6 times the quadratic term, which is 6x squared plus 13x plus 43. Okay, then plus this term, which is a remainder 112 divided by the linear factor x minus 3, and we are done. So this is actually how we can be able to do the synthetic division, okay, of any given polynomial. Note that if the highest term, for instance, okay, if the highest term of f of x, okay, is for instance is, let's say, ax to the power b. For instance, b is the highest term now. Okay, after the synthetic division, the quotient now, that is the result, okay, of the division now, will be a1 x to the power b minus 1. It shows that the new expression has its first term power to be reduced by 1. That is, this is the power of the original expression given to you, that the first term of the original expression. Okay, so after the synthetic division, when trying to put in standard form, it shows that the first term of the new quotient, okay, or quotient polynomial, okay, will be reduced by 1. That is why I have b minus 1, okay. So do you see, the first term of this original expression here is raised to power 3, while in the new, or the result of the division, the term is raised to power 2, meaning that 3 minus 1 is now 2. Okay, so that is how we can do this. It's very simple. You can use it instead of a long division method anyway. So it's a choice. It's better to know the different ways to approach a question. So in terms of time, you know how you can be able to work fast. Thank you for watching. Hope you found this helpful. Please do subscribe to my channel.